Okay, everybody, let's come back for a minute here. Um, there are a couple concepts that we touch on in the lesson that I wanted to explain a little further in the lecture here, um, and just to kind of solidify a couple things. So, before I did that, I wanted to bring up that in working with um, the lesson and I helped Lauren out with something, she reminded me that her point is actually about where we declare variables is true for variables that do not belong to the class itself, but belong to a smaller scope. So here in this function here called propagate movement, I made this variable v, and it's used in all these places. If I declared this variable down here, as soon as my compiler catches up, yep, right here I have a squiggly, and it's like, I can't use this before it's declared. So for these variables that are declared inside the body of the class itself, we can declare them wherever and use them inside the class. But for the ones that are declared inside of a variable, or I'm sorry, inside of a function, they must be declared before they can be used. So that's a little difference. I wanted to talk a little bit about enums or enums. So I've got an enum here, or an enum. It's an enumerator, or an enumeration, I'm sorry. So you can say it however you want. It's fine. It is called cardinal direction. And what do you notice about it besides the green squigglies? Ignore the green squigglies. What's inside of it? The perva.
They're like numbers?
They're numbers, yeah. There's numbers and equal signs and words. Yes, exactly. So there's numbers and words. And that's like a pretty good definition of what we're getting to here. So an enum is a mapping of numbers to words in a way. It is a way for us to use words conveniently to represent numbers where otherwise it would become very confusing what we meant. So think about if you had something that you wanted to keep track of, and you could say like, it's got all of these different states. Like I wanted to keep track of my pet's mood, and it could be like hungry or like grouchy or happy or content or all of these things. You could have all of these different ways to talk about it. In code, you could represent those by a bunch of strings. You could have like a bunch of strings that had those literal words in them. But then every time that you wanted to use those strings, you would have to make sure that you always type the right string, or you would have to reference some variable somewhere that held that string. So that's kind of prone to error. It's not as fast for the computer to do. Computers like to work with numbers much more than they like to work with letters, and strings and things like that. Strings are harder to compare than two numbers for the computer. It has to do more work. So we came up with these um, fun things called enums, because the other thing that we could do is represent those states using numbers. So in your head, you could say like, all right, well, 0 is going to mean happy, and 1 is going to mean grouchy, and 2 is going to mean fed, and 3 is going to mean full, and I'm just going to write these down somewhere and remember what they mean, and then whenever I type 0 here, I'm just going to remember that that's what that means. And I'll compare it against 0, and like I just have to know that that means happy. Well, that's even more error prone than strings, because you're probably going to forget at some point what something means. And if somebody else has to read your code, then it just looks like a mess. You're like, what does like mood equals 0 mean? I don't know. Um, so that's where these enums come in. So I have mapped these cardinal directions to numbers. 0, 1, 2, and 4 for some reason. I really skipped 3, which is a thing you can do. Um, I don't know why I skipped 3. That's actually bad, but whatever. So for our purposes, it's fine. But just to show you that these are, in fact, mapped to these numbers, I'm going to go up here to my player input controller, and I'm going to declare a cardinal direction, my direction. I'm going to go over here. It's going to load up. Of course, it's going to probably be right here where no one can see it. And it's going to compile. There it is. So right now it says my direction's north. I'm going to set it to south. And Unity's going to serialize that. I'm going to go back over here. I'm going to go to my cardinal direction. And I'm going to say south is now 0 and north is now 2. I'm going to come back. What do you think is going to happen? Lauren thinks it's going to say north now. Let's see what happened. It does. I didn't change it in the inspector, but I changed what the backing number here is. And if I change it back, we should get our old result. Doop, there it is. So enums are a good way to represent states a lot. They also are handy because they let you define a series of numbers and not care about any more. So it's like, I only care about 4 states. There are no more cardinal directions than 4, because there aren't any more cardinal directions than 4. There's not a 5th one. I don't need to care about a 5th one. Nobody should ever be able to give me a 5th one. And if we do, we have a serious problem. So, or a 3rd one. So, it's useful for things like switch cases, which we haven't got into yet. But switch cases can, Visual Studio will auto-populate all of your enums enumerations inside of the defined enum for you, which is super handy. And then you can also have a thing called default, which is like, if it doesn't match any of the rest of the things, do this thing. And you could log an error or something. If you get to that point and you're like, I handled every case that I know about, then maybe somebody went along and added to your enum when you didn't know about it, and now something's broken. But at least now you know before it gets out to production, hopefully. So that's a little bit about enums. We've just got a few minutes left, so I want to talk about null and exceptions. Did anybody get to those words at all? Cool, we got one person. So, null. Does anyone know what null means? It's really close to another word that you used in a different class. Haley? Yes, it means a very similar thing to void, which is just like nothing. It's just like it's the code representation of nothing. I got nothing for you. You can't use this at all. And it's used for things that are reference types. So there are certain of our basic types, like integers, floats, that can't be null. because that doesn't make any sense. It has to be something. Even right.
Oh my gosh.
It doesn't right. It doesn't. Zero, which is like the mathematical representation of nothing, is still a number. So you can't like have a concept of a number that is less nothing than zero.
It's like an institution called even.
Yes.
There are some languages that count zero as a multi.
Right.
Stop it.
So so even if you declare an integer and you never assign it, it has a value. It has value as soon as you've declared it. Same thing for booleans. They have a value as soon as you declare it. That the value is false immediately, unless you assign it to true. Because there are only two states, and you can't have a third state. That's not the world that booleans work in. So, but what if we have all this complex data, and you wanted all these things like arrays and numbers, and all of it was grouped in this class, and you went to go get it, and you got nothing instead? How do you tell another class or the same class that you've got nothing? It's the word null. And so you return that instead. Because sometimes you're telling in your declaration, you're like, I'm going to give you this class back. But if you can't actually get that class, what you give them is actually null instead. Because you can't not return something, but you can return nothing. Does that sentence make sense? So you can't. It's like it's like if I borrowed your phone and you were like, "Can I have my phone back, please?" I couldn't be like, "No," and just be like, "No." I would have to be like, "Okay, yes, here you go," and then like try to give you this, which is like nothing. And they're like, "That's not my phone." And I'm like, "Yes, but I am returning it." That's the contract I made. It's just null. So that's sort of how the compiler works with null. Um, I've only got a minute. So exceptions are another way to handle um, returning when you don't want to return. So null, if you try to access null like you were going to access the class, will throw a null reference exception. It's just a bunch of fancy syntax that means like something went so wrong and I looked for something and I got nothing instead. And I tried to do something with nothing and I could do nothing with nothing. And now everything is broken. Um, so instead of doing that, you can throw your own exception that gives you more information about what happened. Instead of saying, well, here's just null, you could say, hey, you forgot to give me the right information to go get that thing. And so I can't. Or I looked everywhere and you gave me this data and nothing happened. You can give more detailed feedback about what happened. And so if you run into that exception while you're testing your game or you're testing your code, then you know what to do to fix that without being like, well, okay, so I got null, but what does that mean? If you know what it means in the function itself, it's nice to tell another programmer or yourself. So that's super brief overview of null and exceptions. It's time, but I want to let everyone know that next week we have some special guests. Do you want to say more about that, Emma?
Sure. So I'm a student at UNO, and maybe some of you have any of the students.
We have some return students from that class.
Yeah, so I'm part of a club of women in IT called the ACMW, and next week we'll have a bunch of students come in and I'll just kind of